Okay, let's talk about my favorite operating system, the Macintosh operating system. In particular, we'll talk about a couple of the Macintosh file systems that are most prevalent. Some of the things you should understand about the Mac operating system. Just like Windows, it's gone through a heavy refurbishment from the time that it came out in 1984 until the present day, making it 22 years old. And the earlier versions of Macintosh were proprietary. The code that was used for the kernel and the operating system and the graphical user interface was all proprietary. But around the year 2000, the Macintosh went over into a completely new refurbishment into a Unix-based operating system, which means now it works, although it may look and feel like the old Macintosh, it works completely differently underneath, and now it's really industrial strength, just like any Unix operating system is. It's very powerful, very extensible, and the great thing about it is you can use the Macintosh just like you would a regular Macintosh, or you can drill down, open up a terminal, and use it just like you would any Unix operating system. And so there's something called a Darwin Core, which is Darwin Core is the free Unix-like operating system that serves as the core operating system of the Mac OS X, and it was built out of BSD 5, the Berkeley Standard Distribution version of Unix. And so if you know BSD, it's quite easy to move yourself over to the Macintosh. And there's been quite a few different file systems. There was the old Macintosh file system, which we are going to talk about, which is completely different from the file systems that have been in use since the year 2000, and even a little before that. Before that, there was something called the hierarchical file system, which was used on the Macintosh back to, I believe, version 8 of the old Mac. That was pre-Mac OS X. And then around the year 2001, I believe, they came out with the Hierarchical File System Plus, which is an extended format of the Hierarchical File System, and that's what we're going to be talking about today. When you first attempt to install Mac OS X on your hard drive on a Macintosh, it gives you the option of either installing on a HFS Plus file system or the Unix file system. And the Unix file system is akin to the old FAST file system that's used by BSD and some other Unixes. And essentially what that does is it limits what you can do on the Macintosh. It makes it less Macintosh-like, if you will, as we'll see later, because there's some things that the HFS Plus provides that the old Unix file system does not. And so typically, even if you're a Power Mac user, you're going to want to install with a Hierarchical File System Plus. There's also some things called a File Manager and Finder that we'll talk about. And we'll see that actually a file on the Macintosh actually has more than one part to it. It has something called the data fork, which essentially holds the content, and it has a resource fork, which actually holds the resources that actually describe some of the file's attributes. So if you think about that for a second, think back to the NTFS, the master file table, is that there were in the master file table, each file was capable of holding a number of different attributes, and in fact a number of different streams. And essentially, it's my understanding that the reason NTFS came out with the capability of multiple streams is so that it could interoperate with the Macintosh. I'm not sure if that's folklore, but that's the way I know it. So what is this thing that they call the Finder? The Finder is the default application that you boot into, and is used on the Mac OS and OS X operating systems, and is responsible for overall user management of files, disks, network volumes, and launching of other applications. So it's essentially acting like the shell on other operating systems. However, it's got a graphical user interface, and we'll see that in a moment. And it was introduced with the very first Macintosh computer, and it's gone quite a few changes, and it underwent a total rewriting when in 2000 when Apple switched to the Unix-based OS and Mac OS X from the previous versions of the Mac OS. As you see here, if you look at the Finder, this looks very old, and when I first started using Macs back in I was going to say, actually, I was using Macs back in 1988, but before that, yeah, I guess that's right. I'm having trouble remembering when I started using Macs, but I had a Mac 2 CI, and this is kind of the interface that it looked like. It looked totally different from Windows, outside of the fact that it was a graphical user interface. But it was very simple, and it was very easy to use because you could just use drag and drop. And as you'll see now, as the Finder, as the Macintosh moved throughout the ages, it became more colorful. I also used this version of the Mac around version 8.2 to 9.1, and it became even more user-friendly. It got more colorful. However, the early versions of Mac from 9.2 and before were very, very slow. And I think that's one of the reasons that it was easier to use Windows is because Windows was lighter, even though it wasn't as powerful. It was a little lighter and a little quicker than the Macintosh. However, even back then, I still enjoyed using the Macintosh because it was so easy to use. But realize there's no way to get at the internal guts, that is the code, like from a command line interface here on the early versions of the Macintosh. But once you went to the Mac OS 10, the original version, just 10.0, then it was built upon Darwin, which was built upon FreeBSD, and it gave you the capability of actually drilling down and opening up a terminal and actually interacting with the files just like you would under Linux or any version of Unix. And this is just showing my desktop right here, and it looks very similar to the previous ones, as you can see here, but it's totally rewritten. It's very, very stable, and I can't speak highly enough of it. And if you want to look at some of the opening up a terminal and seeing some of the files that are included and directories that are included within the root directory here, you see that there's going to be some things that are, this looks fairly primitive, I'm sure, to most of you, but if you look at things like the volumes directory, the volumes directory is where the volumes are actually mounted right in here. Users is akin to the home directory under most distributions of Linux. You have developer files, library files that are used for all applications, regardless of user on the hard drive. You have networking and system files right here. Here you have the etc directory, which is going to include, what do you think that is? We're calling back to our Linux. That's going to be where our configuration files, some of those are located. The binary directory for binary executable files. Here you have the Mach kernel. This is built upon a microkernel called the Mach kernel. You have options, private, SBIN, which is going to be for super users. We have temp files and var directory and user files. So if you compare this to the directories in FreeBSD, you see there's going to be some similarities between those, although there's not going to be a one-to-one mapping between them. Here we see what's in the users directory. Here we have 3 different users. We have share directory where everybody can share among files among users. When we have 2 regular users here, JPC and PC. If we look over here to the UIDs and the GIDs, notice here we have the common root user right here, and then we have JPC and PC here. Over here we have 2 groups called admin, or excuse me, 1 group called admin, and then we have something called a wheel group. And if you'll recall, a wheel group is a group that that is created so that an administrator can add somebody to the wheel group so that they're allowed to SU to root. If you're not in something called the wheel group, that means that you can't, even if you know the root password, it doesn't allow you to SU to root. And so you see over here you have the typical listings of the permissions, read, write, and execute. And here you have the sticky bit set for these 2 right here, the sticky bit set here, and so it looks very similar to what we're accustomed to when we're looking at command line interface for a Linux or Unix-based operating system. And here we have the default directories that are included when you create a user under Mac OS 10. Notice here you have something called a bash history, and this is going to be a bash shell right here. And so the bash history, anything that's typed at the command line at the bash shell is going to be included in here. Here I've set up GNU PG, and then you have, these are the default directories that are created. There's a desktop, a documents where you can keep all your documents, and then for files that or applications that you download on your computer and run just within your account, there's going to be library files located in here. And so anything regarding web history or anything like that, or mail, will be included in here. And then we have some multimedia directories right here, movies, music, and pictures. And so actually you can put anything you want to in here, but it's just a way to organize your directories. Then we have sites, so you can actually create an HTML page, and if you drop that in there, then it's going to be accessible to the public if they know the right URL, and just public files for if you want to share different share files with other users. Okay, getting back to what I was talking about with respect to multiple forks in a Macintosh file. Here we have the Macintosh file structure, so we have a single file, however it has two separate attributes. Were called forks, the data fork and the resource fork. And so on a file system that understands forks, you're going to have a data fork, which is going to contain the content of the file, and then you're going to have the resource fork. And the resource fork holds information such as the resource map, the resource header information for each file, Windows locations, and icons. And so this is like not containing content, but actually the overhead associated with this file. If you copy this file, let's say, to a Windows computer, then it's going to lose everything over here in the resource fork, because current versions of Windows don't understand the Macintosh file, so all you're going to end up getting is the data fork information. So the data fork typically contains data that the user creates, such as text or spreadsheets, and realize that on the Mac OS the resource or the data fork can be empty. So it doesn't have to contain information in either of those. But recall that if you do copy this to a file system that does not understand multiple forks, that this resource fork will be lost. So all that will remain will be the data fork. Now let's talk a little bit about the Macintosh file systems. And we're not going to talk about the older Macintosh file system, but we'll start up with HFS, which came out with OS 8.1. And it was a powerful operating system, but it has since been replaced by HFS Plus, which is the preferred file system on the Mac OS X now. And the reason is it provides a lot more resources for the developer and the user, including journaling. If you recall what journaling was used for that we've mentioned previously, was for keeping track of transactions that are occurring, and so that if your computer goes down during the middle of a transaction, the journaling log file actually has the information as to the transaction that was to occur, and so it can go back and look at that and either revert to its previous state or go ahead and commit that transaction. It also includes quotas, so you can actually set up a quota on individual users. So you can set up, for example, 1 gigabyte or 20 gigabyte quotas, so that users can't just continually increase the number and sizes of the files that are located on the hard drive. There's also the ability to get at Finder information, metadata. You can have multiple encodings, such as ASCII and Unicode. It also provides now for hard and symbolic links, if you recall what a hard and symbolic link were in Linux, for aliases, and support for hiding file extensions on a per file basis. And HFS Plus uses balance trees heavily for many of its internals, and we'll touch on that just a little bit in a few minutes. Okay, some of the reasons why HFS is, while it's architecturally similar to HFS, it's got quite a few improvements, including it now uses 32 bits for allocation blocks instead of 16 bits, and of course, since 32 bits is much larger than 16 bits, that you can have much more, many more files on an HFS Plus formatted hard drive. Now you can have long file names up to 255 characters, and you recall when that came out, when Windows got that capability. That was with the virtual FAT, which is Windows 9 OEM. Oh gosh, I forgot. OEM B, I think that's right. And so you can have long file names under HFS. You can also now have Unicode-based name encoding. And so now one of the great things about the Macintosh is that you can have it in any language. It can be internationalized because it understands all the language. File and directory attributes can be extended in the future as opposed to being a fixed size, and so that's one of the features that allows for extensibility of the file system. And now non-Apple systems can boot from an HFS Plus file system because it includes a startup file which tells it where to execute the boot code. And finally, the largest file size is now 2 to the 63rd bytes. Very, very large files. Later on, we'll see a comparison between HFS and HFS Plus files in terms of file sizes and volume sizes. So some of the core concepts you need to understand. An HFS Plus volume contains 5 special files which store system structures required to access the file system payload, which includes folders, user files, and their associated attributes. And these special files are called the volume header, the catalog file, the extents overflow file, the attributes file, the allocation file or the bitmap file, and the startup file, which we just mentioned. As we go through these, try to think about how these map to the concepts we had before under FAT and the in TFS. As we'll see that there are some, obviously there's going to be some similarities between them. So the catalogs file is a special file that describes the folder and file hierarchy on a volume. So a catalog file will hold information about each file or directory, and it's organized in the form of a balanced tree, which allows for quick and efficient searches through a large folder hierarchy. And each file and folder name can consist up to 255 Unicode characters. And we'll actually look at some of the code and the encoding involved with this a little later on. The attribute file is a special file which contains additional data for a file or a folder. And this too, the attributes file is organized as a balanced tree as well. And the extents overflow file, and this is dissimilar to what we saw in the FAT or NTFS, and this deals with fragmented files. HFS Plus tracks which allocation blocks belong to a fork by maintaining a list of the fork's extents. And this is a key term here. An extent is a contiguous range of allocation blocks allocated to some fork represented by a pair of numbers, the first allocation block number and the number of allocation blocks. So for a single user, the first 8 extents of each fork are stored in the volume's catalog file, and anything greater than 8 extents will be contained in the extents overflow file, which is also organized as a balanced tree. And so again, each file's extents are tracked in the extents overflow. Each file's first 8 extents are stored in the volume's catalog files, and so that's similar to what we would call the run lists under the master file table. And anything over the 8 extents will be contained in the extents overflow file, and there will be 2 pairs of numbers associated with each extent, and that is the starting block and the block length. Other special files. There's something called an allocation file, which specifies whether an allocation block is used or is free. What is that similar to in the master file table under NTFS? NTFS, not the master file table. That's similar to the volume bitmap, which indicates whether a block is used or not. Something called a startup file, which is another special file which facilitates booting of non-Mac OS computers from HFS Plus volumes. And finally, there's the bad block file, which prevents the volume from using certain blocks because the portion of the media that stores those blocks was defective. Where would we find that information in the FAT? That would be located in the FAT, under the FAT file system. And this is how it looks linearly, how the placement of the special files occurs. You have the volume header starting above the first reserved 1024 bytes. You have next you have the allocation file, which shows which blocks are allocated. Then you have the extents overflow file, which holds information about files and where they're located. At the catalog file, which holds file attributes, and it holds information on the first 8 extents of a file. Then we have attributes file, which holds information, further information on each file's attributes, and then we have the startup file. Okay, just looking at some of the specifics about HFS Plus. Recall that HFS Plus file names can be up to 255 Unicode characters, and this is just showing the code and how this is structured. So you have a struct, if you recall what that is. And you have a 16-bit integer here showing the length of the name, and then you have here you have an array of 205 Unicode characters, indicating that right here that each name can be up to 255 Unicode characters. HFS Plus Permissions. For each file and folder, it maintains a record containing access permissions defined by this structure right here. So if you recall, if you look, this looks very familiar. The owner ID, the group ID, administrator flags, the owner flags, these are going to be the permissions, the file mode, and then the IDO number. And the IDO number, if you recall, we talked a little bit about this before, but the IDO number is going to be a unique number that is used by the operating system and file system to track a file. The link count, recall that we can have hard links and we can have soft links as well. And then we have data structures that is used to represent fork information. And recall there's 2 such structures. We have one for the resource and one for the data. And both of these are going to be stored in the catalog record for each user file. In addition, the volume header contains a fork data structure for each special file. And recall there's 5 special files. And this is just showing the HFS Plus fork data have a logical size. We have a clump size, which is the size of the data unit, and the number of total blocks associated with that fork. Notice that we also have an HFS Plus extent record, which holds extents. And recall that the catalog file record for each file is used in the catalog B tree to hold information about a particular file on the volume, and that's described by the HFS Plus catalog file type. And so each file or directory will be represented by one of these records. So we have a record type, the flags, reserved, the file ID, which is the catalog node ID, the creation date, the content modification date, the attribute modification date, access date, the date it was backed up, the permissions for the file, any user info and finder info, the type of text encoding, which can be some Unicode, and this is reserved as well. And then notice down here too, you have 2 other data structures within this HFS Plus catalog file. You have a data fork and you have a resource fork. Okay, the extents overflow file. Recall that HFS Plus tracks which allocations blocks belong to a file's fork by maintaining a list of extents, which are contiguous allocation blocks that belong to that file, and they categorize that in the appropriate order. So each extent again is represented by a pair of numbers, the first allocation block number of the extent and the number of allocation blocks within the extent. And so the file record in the catalog B tree contains a record of the first 8 extents of each fork. And if there are more than 8 extents in a fork, the remaining extents are stored in the extents overflow file. The allocation file is used to keep track of whether each allocation block in a volume is currently allocated to some file system structure or not. And the contents of the allocation file is a bitmap, so it's going to be 0 or 1. The bitmap contains 1 bit for each allocation block in the volume. And so if a bit is set, the corresponding allocation block is currently in use by some file system, and if it's clear, that means it is available for allocation. And this is just showing the check to see whether an allocation block is being used. It's Boolean, so it's going to be 0 or 1 here. Is allocation block used? And so the inputs for this are this allocation block and allocation file contents. And notice that this returns either, here it says not equal to 0, so it's going to return a 1 if it's used, and otherwise a 0. Okay, looking at some of the older Macintosh file operating systems, and shows you the limitations. Files per folder, 2 to the 15th power for Mac OS 8 and 9. Once you get to Mac OS 10 and above, it has 2 to the 31st. If you're using HFS Plus, that's going to be an unlimited number right here. And recall right here we're talking about HFS being used. Maximum file size 2 gigabytes, 2 terabytes, 8 terabytes, 16 terabytes, and 16 exabytes, which is 1,000 terabytes. And you see the same thing over here, the maximum volume size over here, 2 terabytes, all the way down to Mac OS 10 and 10.1. Once they got to 10.2 and 10.3, it went up to 8 terabytes and 16 total. And finally, we're using HFS Plus. The maximum volume size can be 16 exabytes. Okay, let's skip that last section. Let's talk a little bit about using Macintosh forensic software. Originally there was a program called Expert Witness, written by ASR Data, now owned by Guidance Software, and it's no longer called Expert Witness. That doesn't exist, but it's called InCase, and that can be used for actually looking at some of the earlier Mac OSs. And now there's a company out of San Francisco called Black Bag Technologies, which deals specifically with Macintosh forensics tools. And so that's for any of the earlier Macintosh operating systems, and there are quite a bit of those out there, so one of these days you might run into one of those. However, if you're working with or examining a Mac OS 10 system, then you can use any Unix or Linux forensics utility, and hopefully we'll be able to show you some of that later on. So once you learn about Unix and Linux forensics tools, it's the wonderful thing about that is that can be used for Windows, they can be used for Linux or Unix, and they can also be used for Mac OS 10. And some of the resources that were used in putting this together. And then next time we're going to talk about, spend a little more time talking about Unix and Linux file systems.